So before we go on with instantaneous rates number 7, I want to point out a correction to the homework, which is something that I left out of here in this layout was 41 through 44 all. I forgot to put that in there. 41 through 44 all. So this is the correct homework assignment. This is also posted on Google Classroom and on the website on the homework page, so you can be sure that you're doing the correct thing. Okay? It's also in that weekly planner if anybody ever uses that. I have no idea if anybody ever looks at it. But I do it in case somebody does. All right, so the next problem is about bacteria. So this time we're going to have units and we're going to have interpreting in context. So we have population of bacteria in a culture increases according to this function, all right? So, but we're doing the same A, B, C, D steps. So first we're finding the average rate of change over 3, 4. So that average rate of change is, I'm going to still write B of 4 minus B of 3 over 4 minus 3. Remember, the average rate of change is not a limit. It's never going to be a limit. So that's going to be 6.7 times 4 squared plus 2 times 4 minus. Now here's where you have to, like, some people calculate B4 and B3 separately. That's fine. But, you know, when you, ultimately you're going to have to do this with an H in it. So you're not going to be able to take that shortcut because some of it won't simplify. So when I do my B of 3 and I have 6.7 times 3 squared plus 2 times 3, it is imperative that I keep all that in parentheses, right? So it's really nice to have parallel parentheses because this is B4, this is B of 3, right? And then in my denominator, I just have 1. All right. So now look, once I get everything simplified in terms of numbers, then you can just put a number there. I threw all that into my calculator. I did that already. It's 32.9. Now, but this time, all of the rates have an interpretation because there's an applied context. It is 32.9 bacteria per, what's our time scale? Our time scale is hours, not seconds. So 32.9 more bacteria per hour. All right, that's a pretty modest spread of bacteria, frankly. Maybe if it's like 32.9 million, that would be one thing. All right, anyway, that's part A. It's 32.9 bacteria per hour. All right, part B, we're supposed to do 3 to 3 plus H. So here's where we'll have to be really careful with the parentheses. So once again, oh, I forgot what I was going to say. Once again, I've forgotten what I was going to say. This is B of 3 plus H minus B of 3 over 3 plus H minus 3. So, yeah, well, you're going to be plugging 3 plus H into T squared a lot, right? So get used to that. That's going to be 6.7 times 3 plus H squared. I mean, it could be a cubic. It would just be more work. Plus 2 times 3 plus H. So sometimes people get a little bit confused about how to plug the 3 plus H into a little bit more complicated function, right? You're doing a composition of functions here, right? So this whole thing is just B of 3 plus H, and I've replaced each of the T's with 3 plus H. Okay, and then I'm going to say minus, and I'm going to put my big parentheses for that right away. So when I just do B of 3, well, I could have worked B of 3 out previously. Maybe I should just do that now. Maybe I did it in my notes somewhere. It's 66.3, is that the correct number? Yeah, it's 66.3. Then I don't need the parentheses, right? Yeah, but I put them anyway, so whatever. All right, now my denominator simplifies to be just H. All right, so now I'm going to, in my next step, expand out the binomial. So I'm going to say this equals 6.7 times 9 plus 6H plus H squared. Notice how I don't mind writing the entire expression as many times as it takes, simplifying one thing at each step. I still have my denominator of H. Now I'm going to distribute my 6.7. So I'm going to get, I did this ahead of time. I wasn't, it was a long time ago. I can't always read my own notes because I'm not actually as organized as I pretend to be. Like this is what my notes normally look like. That's not too bad, right? That's just my sketch out notes. Anyway, you don't want to see my inner workings. Minus 66.3. all right, over h. That's a plus right there. Yeah, okay. All right. So things that you will notice is that 60.3 plus 6 equals 66.3. So the 60.3, the 6, and the 66.3 will cancel as we expect the constant terms to always do. And then we have 40.2h plus 2h squared over h. And then we leave it right there, but it is still bacteria per hour. All right, so the average rate of change of bacteria over the period 3 to 3 plus h is 40.2h plus 2h squared over h bacteria per hour. I'm not reducing it at this point because I don't have a limit to reduce. All right, that's part B. Part C is we're going to take the limit of that. So limit as h. So this is starting to look like, right, there's like a standard procedure. You follow the same way every time. And this is something you're going to have to do on tests, both for AP and for my class and for your college calculus class probably too. So I have, what did I have? 42.2h plus 6.7h squared over h. I'm doing limit as h approaches 0 of that. So now, because it's a limit, I can reduce it as long as I carefully include the limit statement again. 42.2 plus 6.7h. Let's put that in parentheses to be nice, although some people wouldn't. And then we will evaluate by substitution. Since I'm evaluating by substituting the 0 for the h, it is no longer a limit, so I no longer write a limit statement. I will explicitly represent the substitution, however, and then I get 42.2. The units are bacteria per hour. Okay, part D, the instantaneous rate of change. At t equals 3 hours, the rate of change of bacteria, I mean, I could say instantaneous rate of change, right? The instantaneous rate of change. Instantaneous rate of change of bacteria is 42.2 bacteria per hour. And that's how you find an instantaneous rate of change using limits. And yeah, I'll say more about that in the final video.